equal to x plus 3y square minus z cube, v is equal to 4x square yz, w is equal to 2z square minus xy. Then find del of u comma v comma w divided by del of x comma y comma z at the point 1 comma minus 1 comma 0. Here also we have to find the Jacobian for the function u v w with respect to the variables x, y, z. Also they have given we have to find the Jacobian at the point 1 comma minus 1 comma 0. Here 1 minus 1 0 is the value of x, y and z. We have to find the Jacobian for the function at the point 1 comma minus 1 comma 0. First take the given problem. U is equal to x plus 3y square minus z cube, v is equal to 4x square yz, w is equal to 2z square minus xy. We know that the Jacobian for the function u v w with respect to the variables x, y, z is given by determinant of del u by del x, del u by del y, del u by del z, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y and del w by del z. In the first step we have to find all these values. In next step we have to find these values at the point 1 comma minus 1 comma 0. After finding these values we can substitute in the given formula. Then we get the Jacobian for the function. For that, first take del u by del x value as here del u by del x. To find the del u by del x, first you have to consider this function, that is u is equal to x plus 3y square minus z cube. So del u by del x value is nothing but we have to treat y and z as constant. We already know that to find del u by del x we have to treat y and z function as constant. So we know that the differentiation of x is 1. Hence we get del u by del x value as 1. Also we have to find del u by del x at the point 1 comma minus 1 comma 0. Hence we can take del u by del x value as 1 itself. Here we know that del u by del x also can be written as simply ux. Hence we get ux at the point 1 comma minus 1 comma 0 value as 1. Similarly, del u by del y value is, here we have to differentiate this term u with respect to y partially, means you have to treat x and z as constant. Hence we get here differentiation of 3y square as 3 into y square differentiation is 2y. Hence we get 3 into 2 is 6y. After finding del u by del y we have to find the values, that is uy at the point 1 comma minus 1 comma 0. That means we have to substitute y value as minus 1. Hence we get 6 into minus 1 is minus 6. This is our del u by del y value. Similarly we have to find del u by del z. That means we have to treat x and y as constant. Hence we get del u by del z value as minus, here z cube differentiation is 3z square. Hence we get del u by del z value as minus 3z square. Again we have to find del u by del z value at the point 1 comma minus 1 comma 0. That means we have to substitute z value as 0 here. Hence we get del u by del z value as 0. Or we can simply write it as uz value as 0. Similarly we have to find del v by del x value. For that, consider this function v is equal to 4x square yz. Here del v by del x means we have to treat y and z as constant. Hence we get 4yz as constant. Differentiation of x square is 2x. Hence we get 4 into 2 is 8xyz. This is our del v by del x value. Or simply we can take it as vx. We have to find vx value at the point 1 comma minus 1 comma 0. That means we have to substitute x value as 0, y value as minus 1 and z value as 0. Here 0 multiplied by anything is 0 itself. Hence we get vx value as 0. Similarly, del v by del y value as, here we have to treat 4x square z as constant and differentiation of y is 1. Hence we get del v by del y value as 4x square z. After substituting x value as 1 and z value as 0, we get vy value as 0 itself. Similarly, we have to find del v by del z. That is, we have to treat 4x square y as constant. Differentiation of z is 1. Hence we get del v by del z value as 4x square y. Similarly, we have to substitute x value as 1 and y value as minus 1. We get vz, that is del v by del z value as minus 4. In the same way, we have to find del w by del x. For that, consider the function w is equal to 2z square minus xy. We have to treat y and z as constant. So here constant differentiation is 0 minus, here differentiation of xy, that is we have to treat y as constant. Hence we get minus y as constant into differentiation of x is 1. Hence we get del w by del x value as minus y. In next step we have to substitute at the point y is equal to minus 1. So we get wx, that is del w by del x value as 1. That is minus of y value is minus 1. Hence we get minus 2 minus plus 1. Similarly, del w by del y value is, here we have to treat x and z value as constant. So this term is 0. Minus, here to treat x is constant, hence we get minus x value as del w by del y. We have to substitute x value as 1, we get the value of wy, that is del w by del y value as minus 1. Similarly, we have del w by del z value as, we have to treat x and y as constant here, this term is 0. Differentiation of 2z square is 4z, hence we get del w by del z value as 4z. Substitute z value as 0, we get wz, that is del w by del z value as 0. After finding all these values, we have to substitute in the formula. We get as del of u comma v comma w with respect to x comma y comma z is determinant of 1 minus 6 0 0 0 minus 4 1 minus 1 0. Substituting all these values here, we get this. In next step, we have to expand the determinant, that is 1 into, here we have to cross multiply this, that is 0 into 0 is 0 minus, here minus 1 into minus 4 is plus 4, hence we get 0 minus 4. Here minus of minus 6, that is plus 6 into, here 0 into 0 is 0 minus 1 into minus 4, hence we get minus 2 minus plus 4, plus 0 into, here 0 into minus 1 is 0 minus 0 into 1 is 0. We have to expand carefully. This is a very important step to expand the determinant. Next, simplify the term, we get as, here 1 into minus 4 is minus 4 plus 6 into 4 is 24. Here this value becomes 0. Hence we get the Jacobian for the function u, v, w with respect to the variable x, y, z value as 20. This completes the problem.